Hello, dear participant. Welcome our conference. The conference title is Investigation of Synergetic Effect of Alkali Activation and Modern Application in Reactive Dyes of the Lyocell Fabric. And my name is Murat Ayberk Baran. Now, I'm a PhD student at Bursa Yıldız University with my professor, Dr. Behçet Beceri. We did some experiment about dyeing Lyocell fabric with alternative and more stronger and more darker colors than usual dyeing. As an introduction, a lifestyle fabric known for their sustainable profile and high crystallinity often requires surface modification to enhance dye uptake and color fastness. In this study, the synergetic effect of alkali pretreatment and modern application on the dyeing performance of lifestyle fabric were investigated using reactive dyes. The experiment design focused on a blue color palette applied at 4 different dye concentrations. As I can talk about Lyocell fabrics, they have sustainable origin. They come from regenerated cellulose fiber produced via an eco-friendly closed-loop solvent spinning process. Its name NMMO. This solvent can be reused by 99.9, and also there is a leftover 0.01 point. It can be degenerate in the nature. Also, they have a really high strength, exceptional tensile strength, both in dry and wet states, outperforming cotton and viscose. Also, that causes the lyocell fabric in upcoming years become like more popular and more wide usage at the textile industry. Because when we're using cotton, we have to farm, we use lots of water. They have lots of impurities, we have to use lots of water and chemicals to get rid of those. The lyocell fabric has a really excellent moisture absorption and breathability, regulating thermal comfort. The lyocell fabric have a fibrillation tendency. They have microfibers can split from the surface when it's wet, allowing for unique peat skin effect and requiring enzyme treatment to control. Their aesthetic is like smooth surface, a profile resulting in a soft touch, gentle feel on the skin, and elegant drip. As the right picture, you can see the lyocell fabric under the microscope. Uh, their fibers looks like almost circular, but the cotton is like more kidney shape, if you know. That means that lyocell fabric has like more strength, and they are like brightest when they before dyed. Also, I want to talk about reactive dyes. Reactive dyes in the industry, like most using dye when we're dyeing cellulose. They have lots of advantages. The most important, reactive dyes make covalent bonding. They forms a permanent chemical bond with hydroxyl group of the cellulose fiber under alkaline condition. As we know, the covalent bonding is the strongest bonding in chemistry. They have high fastness, and they have like brilliant color palette, and they have like amazing water solubility. The only disadvantage is they have hydrolysis risk. A portion of the dye inevitably reacts with the water instead of the fiber, requiring through washing off to remove unfixed dye. Thus, we want to use a metallic mordant salt in this experiment. Metal mordant salt, as we can see, they are literally salt. But they like heavy metal salt most of times, like aluminum, iron, or copper, used to bond dyes in the fiber. And this metallic mordant salt in this textile industry with the dyeing, they're using it a very, very long time. They made a complex formation, creates a coordination complex chelation between the fiber and the dye molecule. At that cost, when the mordant and the dye becomes together, the color molecule becomes bigger, and they have more bonds to hold, making bondage with the fiber. That cause improve fastest improvement, especially light and wash fastness. Also, they can give us like shade alteration, can drastically shift the final color of the dyed fabric depending on the metal ion used. But the only negative environment effect, some of mordants have like heavy metal mordants can carry ecotoxicity concerns, but at this time they're all banned from the industry. And all in this experiment, all the chemical we use are totally can be reused and can be eliminated in the water. We use alkali treatment with sodium hydroxide. It's a really special treatment before dyeing. Sodium hydroxide causes fiber swelling. It increased the amorphous region in the fiber that caused maximizing the accessibility and exhaustion rates. Also, a reactive dyes can fixation under alkali condition. We use this as an advantage and improve fiberglass tensile strength and dimensional stability. But we need to really care attention the alkali concentration and the temperature before we apply it. As how we can understand our result, in the textile industry, we must use a Scilab color space. It's like a standardization measurement. It's like a fingerprint of any color. Because when we use spectrophotometers, it shows the exact coordinate in the Scilab color space. That means we totally identified what a color is. The only important about Scilab color space, there's some of the coordinate names we must understand. We have L, A, and B. L represent lightness and the darkness. A coordinate represent red and green axis. B coordinate represent yellow and blue axis. And we have delta E value that calculates total color difference between a target standard and dyed sample. In this experiment as a material and the substrate, we use 100% lyocell woven fabric. We use as a dye-free fluoropyramid-based reactive dyes. We use in different 4 concentration, 1, 2, 4, and 8. But in the result, I show you only the 4 because the most significant result we can see at 4. As a chemical, we use sodium hydroxide because we did as a pre-treatment. We use sodium chloride during the dyeing. We use sodium bicarbonate to regulate the pH when we're dyeing reactive dyes. Also, we're using some mordant. We only use a 0.5, but also we can use until 5%, but we only use 0.5. And even it shows like really amazing result. As a post-mordant, mordant, we use potassium aluminum sulfate, dodecahedrite, alum, iron, sulfate heptahedrite, tannic acid, and gallic acid. Our dyeing process, as it shows, we start as an alkali treatment at room temperature for 30 minutes. Then we increase the temperature, we add a little bit more alkali, then after we add salt, then after we add acid to make pH 5 to make this metallic mordant salt, because the metallic mordant salt works at the best performance at pH 5. Then after we drop the temperature at 60 degrees, we add dye stuff, we add our salt, and maximum dyeing temperature at 60 degrees, we dye this fabric 60 minutes. Then after the process ends, we add weak acetic acid to make the pH 5. Then we re-added mordant and we treat it with the mordant at 30 minutes and our dyeing is totally finished. As a direct result, I want to show the exact coordinate after we did our experiment. As the most important thing, our goal at this experiment, our goal make the L value like the lowest, K over S highest. That means when the L value is the low, that means our color are darker. But if K over S value is higher, that means our color strength is the most. As we can see, without alkali treatment and without wash fatness, as we can see, dyeing with the iron sulfate has shown the darkest color instead of any other mordant and the blend dyeing. Blend dyeing means we didn't use as a mordant. It's like a control sample for us. Also, as a K over S value, dyeing with the iron sulfate is the highest. But after we did our wash treatment, as we can see, iron still holds the best result and still have the highest color strength. But we see how affects when we do alkali pre-treatment. Before wash, as we can see, alkali treatment shows like the opposite result as we expect. We see the blend dyeing, dyeing with the alum is like way more lighter than without using sodium hydroxide. Also, we can see color strength values have become lower. But there's the interesting result, as we can see, dyeing with the gallic acid and sodium hydroxide shows way better result than without using sodium hydroxide. And as we can see, color strength value is like 24.65. It's a really high degree, almost twice better than control sample. After wash, as we can see, after wash, we lost of the color because the L value becomes 32 to 40. Also, our color strength becomes 11.48. But still, there's a surprising thing. Gallic acid works with sodium hydroxide the best. They still keep the fastness really high, and they still keep the highest color strength. As this result and discussion, and we can say gallic acid shows a phenomenal synergetic effect with sodium hydroxide. It completely overcomes the alkali color loss, boosting initial color strength to a peak of 24.65 and maintaining a brilliant 25.74 after washing. It's act like an ultimate bridge between the swollen lysyl fiber and the dye. Tannic acid and iron like highly effective protective agent, but they are still not showing the best result as gallic acid. As alum fails to stabilize the dye under alkaline condition. It shows like very poor performances of the only sample, resulting in very low phosphorus color yield. As you can see, our reference. And thank you for participation. If you can ask your additional question and possible collaboration, please contact by my mail or via my phone number. Thank you so much.